Hello everyone, I am Nityanand Mathur and I will be presenting CraftSVG, a framework for multi-object text-to-SVG synthesis using layout-guided diffusion. Our goal is to generate structured expressive SVG sketches from natural language descriptions while preserving object count, spatial relationships, and artistic abstraction.
Our motivation stems from a simple premise that sketches are often much better at conveying a conceptual layout than text descriptions alone. A sketch corresponding to a text instantly sets the visual composition.
So where exactly do these existing techniques fail in these multi-object scenarios? First, they struggle heavily with enumeration. When given a prompt like 2 giraffes and 3 elephants in a forest, prior methods like DiffSketcher, Vector Fusion, and SVG Dreamer frequently fail to generate correct number of subjects. Second, they fail at maintaining accurate spatial relationships. For example, accurately depicting a man walking alongside a horse ridden by a woman proves incredibly difficult for these baseline models, often resulting in merged or misplaced subjects. We identified four main challenges causing these failures. First, LLMs tend to return bounding box coordinates sequentially, which disrupts spatial relationships. Second, denoising the foreground and background together leads to semantic leakage. Third, initializing strokes with clip-based or unit-based attention does not properly consider the actual semantics of the scene. Finally, lacking opacity control results in artificial-looking sketches rather than achieving natural depth or artistic effect. To address these issues, CraftSVG introduces three main contributions. The first is iterative layout correction through in-context learning. By iteratively reconstructing the prompt and evaluating reconstruction error or delta REC, we dramatically align the generated layout with original target concept. Our second contribution is per box mask-latent based canvas initialization. By explicitly separating the background and foreground and utilizing masks and key points, we generate a rasterized image that effectively guides the initial placement of strokes. Our third contribution is semantic-aware opacity optimization. We introduce a specific loss function LSOP to control opacity. As shown in these examples, utilizing LSOP yields far more natural and distinct subjects against the backgrounds compared to their models generated without it. Here is a look at the overall CraftSVG architecture. Starting from a text prompt, our layout generator produces object mask and a background. These are composed and passed through a diffusion unit. We leverage two parallel MLPs for mask-latent based stroke initialization, utilizing alignment and opacity optimization losses to render the final SVG. Here are a few results generated using our method CraftSVG. The top row shows abstract SVGs generated with the 64 strokes. By optimizing opacity and semantic awareness, we increase this to 1024 strokes for the detailed sketches and further optimize color to produce a final vibrant clip art in the bottom row. This slide visually demonstrates the evolution of Bezier curves during inference. You can see how the image refines from pure noise at iteration 1 all the way to a clean, highly detailed multi-object scene by iteration 500. We also offer precise user control over stroke abstraction. Increasing the number of MLP layers from 2 to 11 improves control from loose to precise. Furthermore, increasing the number of neurons from 32 to 512 transitions the sketch from simple to highly detailed, maintaining recognizability at every stage. Coming back to the initial multi-object problems, we can see that CraftSVG accurately generates exactly 2 giraffes and 3 elephants without blending them, while other methods are unable to do so. Similarly, CraftSVG correctly positions the walking man alongside the horse while the woman is riding it, whereas the other methods again fail to do so. Additionally, our method successfully handles the abstract or surreal concepts such as Yeti taking a selfie. Our method is also capable of accurate scene text writing, cleanly generating the word stop on a signpost. In our quantitative evaluation against conventional SVG synthesis techniques, CraftSVG outperforms existing models across the board. For instance, our CLIPArt variant achieved the highest CLIPT score of 0.5013 and the highest blip score of 0.5783, beating all other SOTA methods across results. We evaluated various LLMs for layout generation based on 50 unique prompts. After testing models ranging from Llama 7 billion to ChatGPT 4o, we found that Claude 3.5 Sonnet provided the highest average performance score. Therefore, we utilized Claude 3.5 Sonnet for our experiments. In our ablation and canvas initialization, we observed that LDM and clip attention model failed to capture object level detail, while random initialization just adds cluster. Our per mask latent attention is what ensures complete, Detailed canvas coverage. Our ablations on opacity demonstrate that initializing strokes with higher gamma values drastically enhances the contrast between foreground and background. You can see the visual depth improving steadily from a gamma of 0.1 to 1.0. On the ablations of the number of strokes, we found that increasing the parameter count gives the CLIPArt a much more realistic look. We found that the finesse of sketch is directly proportional to the number of strokes it was initialized with. When compared to the existing image abstraction techniques like ClipPasso and ClipPassine, our method yields structurally superior and more recognizable results, which can also be seen in the table. Like any other method, we do have failure cases. Currently, our method struggles to synthesize highly detailed faces while simultaneously maintaining enumeration and spatial relationships. This is evident in complex prompts requiring specific facial expressions or multiple interacting people. To conclude, CraftSVG successfully generates multi-object SVGs by maintaining enumeration and spatial relationships via a per-box mask-latent mechanism. We generate abstract to detailed SVGs through parallel MLPs and iteratively correct layout without needing to fine-tune the large language models. In the future, we aim to solve our failure cases by integrating a phase-consistent attention mechanism. Thank you so much for your time and attention.